Hi guys, today we're going to do page 72, applying parallel lines to polygons. I don't have a video today, a video person, so I'm doing it myself. Alright, the first thing I want you to do is put these notes into your notebook. The first thing is a triangle, which is a figure formed by three segments joining three non-collinear points. We remember that non-collinear means they're not on the same line. They're non-collinear. So if we join 3 points that aren't on the same line, each of these 3 points is the vertex of a triangle. So here we have it. There's triangle, you could either call that ABC, triangle BCA. As long as you put the 3 letters in order, it's fine whichever way you want to call it. But points A, B, and C are the vertices of the triangle. So you see those vertices, A, B, and C. This is also called, I told you, triangle ABC, BAC, or CBA. AB, segment AB, segment BC, and segment AC are the sides of the triangle. So there's one side of the triangle, there's the other side of the triangle, and there's the third side of the triangle. Angle A, B, and C are the angles of the triangle. Angle A, angle B, and angle C. Those are the angles of the triangle. So, one of the things you're going to learn is that angle A plus angle B plus angle C equals 180 degrees. So now at this point, I expect you all to know that a triangle, the 3 measures of each angle, if you took a protractor and measured a triangle's angles, they should equal up to 180 degrees. So if you were given this problem, one angle was 87, the other angle is 35, and you have to find out x. What you want to do is add 87 and 35. Then you're going to subtract that answer from 180, and you're going to get 58, and so x equals 58. Okay? All right, so there are different types of triangles. We're going to talk about the different types. These need to be drawn into your notebook today. The first one is called a scalene triangle. If you notice, none of the sides are congruent. They all have different measures. So when you see a scalene triangle, you'll have different, all measures of each side will be different lengths. There'll be a longest side, there'll be a shortest side, and there'll be a medium side. Isosceles, get used to this one, you'll see this a lot. An isosceles has 2 equal sides. And what you'll find out is if the sides are equal, then the opposite angles are also equal. So I showed you that in the picture. When an isosceles triangle has 2 equal sides, it also has base angles that are equal. Those 2 angles that I showed you congruent are called base angles of an isosceles triangle. So say the word isosceles, draw this in your notebook, 2 equal sides. This is called an equilateral or equiangular triangle. Equilateral means all sides are congruent. That means if this side is, if that side's 5, then that side's 5, then that side's 5. One thing very special about an equilateral triangle is it's also equiangular. That means all angles are equal. And you'll find out that all angles in an equiangular triangle are 60 degrees. So anytime you see an equilateral triangle, you're going to know that the angles are always 60 because you just divide 180 by 3, you get 60. This is called an acute triangle. Acute triangle means all angles are less than 90. If you notice those angles, they're all, that's not a very straight triangle, but all the angles are less than 90 degrees. That's acute. This is an obtuse triangle. One angle is greater than 90 degrees, the other 2 are less, but if there's one angle greater, then it's called an obtuse triangle. Finally, this is a right triangle. A right triangle has one angle that's 90 degrees, as you can see. It also, across from the right angle of the triangle is called the hypotenuse. Hypoteneuse. That's always the longest side in a right triangle. So now you know the word hypotenuse, which is across from a right angle in a right triangle. All right, this angle right here that I'm pointing to is called an exterior angle of a triangle. And you're going to find out that the exterior angle of a triangle should always equal the sum of the 2 angles that aren't next to it. So that angle isn't next to it. We know that angle is 70 degrees because it's supplementary to 110. But these two angles, 57 and 53, those added up together are going to equal 110. So the two angles that are not adjacent to the exterior angle of a triangle add up together to equal the same number that the exterior of the triangle does. So there you have it. 180 minus 110 is 70. So 110 and the other angle next to it is 70. If I added, so you know the degrees and the angles of a triangle are 180. So they should all add up to 180. If you notice 57 and 53, if you add those together, you would get 110. Okay, here's another example. If I have 88 and 32, if I add those together, I get 120, and there's the exterior angle of a triangle. What you're going to do is you're going to copy theorems on pages 72 to 75. You're going to copy the two theorems and the four postulates in your book. You're going to copy the notes from this today's video, and you're going to do classroom exercises numbers 1 through 21. Have a great weekend.